All right, in this video we're going to go a little bit deeper and make sure that we understand a more in-depth process for how to solve stoichiometry word problems. To start with, looking at this equation up here, we want to know what is 1 mole of reaction. 1 mole of reaction presented by the balanced equation above is 1 mole of nitrogen reacting with 3 moles of hydrogen to produce 2 moles of NH3. Okay, I'm just looking at the coefficients. 1 mole of nitrogen, 3 moles of hydrogen, and it makes 2 moles of NH3. You need to know the number of moles of reaction or the number of batches can be obtained by using this formula below. Moles of reaction, or another word for that is batches. From the last page we said it's very similar to what we've been saying, batches. The moles of reaction is the moles of reactants that are given in the problem divided by the moles of reaction that are based on the coefficient in a balanced equation. So where it's going to be the given in the problem or what's asked for in the problem. In this case we're doing moles of reaction, so it's what's given in the problem divided by the coefficient of that substance in the balanced chemical equation. Here's the technique to find the limiting and excess reactants using the moles of reaction method. Calculate the moles of reaction based on the first reactant. Calculate the moles of reaction based on the second reactant. In other words, what we're going to do is make 2 fractions. And we're going to compare them. If there are 2 or more reactants, we would calculate moles of reaction based on each reactant. So it may be more than 2, but most of the time it's 2 fractions. Okay, the reactant with the least moles of reaction is the limiting reactant. All the other reactants, if there's just 1 or if there's 3, all the other reactants are excess reactants. Using the moles of the limiting reactant with the technique that we learned in part 1, in moles part 1, you can also calculate the moles of products that are produced and the moles of excess reactant that are consumed or used. And then we can figure out how to find the moles of excess remaining. This is how. So if you're looking for moles of excess, this is probably the hardest part that more students get this part wrong than any other part. Moles of excess reactant remaining, that's the moles of excess available minus the moles of excess consumed. Okay, what's available, that's given. What's consumed, well, that is found using 0.4. So right here, we can calculate the moles of excess consumed. We're going to talk about some details of that and work through an example. So example 1, 1 N2 plus 3H2 yields 2 NH3 in a reaction vessel initially contains 2.75 moles of N2, 5.64 moles of H2. I immediately know I'm going to have to find the limiting reactant because I've got 2 different amounts given instead of just 1. So the first question it asks me is to determine the limiting reactant and justify the answer. So to find the limiting reactant, I'm going to make 2 fractions. Moles of reaction based on the first reactant and moles of reaction based on the second reactant. So we're going to take the numbers from the problem and divide by the coefficients. 2.75 moles of N2 over, and the number we're dealing with here is 1 because that's the coefficient, 1 mole of N2. Notice that moles of N2, the units actually cancel out, so you have no units. If you wanted, you could write moles of reaction, but you cannot write moles of N2 because those units cancel out. So you can see here 2.75 moles of N2 over 1 mole of N2 is just going to be 2.75. Okay. Then we also have to make a fraction with this number, 5.64 moles of H2. over, and our number for H2 is 3 moles of H2. Okay, so 5.64 over 3, I might need a calculator for that. 5.64 over 3, it's 1.88. It's just moles of reaction. I don't actually write any units for these numbers. If I wanted to, I would say moles of reaction. What I'm looking at is which one produces the fewest batches. That's what these numbers are. They're the batches, or the times we can do the reaction in terms of moles, or moles of reaction. So I've got 2.75 or 1.88. Thinking back to our sandwich example, whichever scenario shows us running out of something, that's our limiting. Well, it looks like I can only make 1.88 moles of reaction, and it's because of H2. So when it asks me what the limiting reactant is, remember our reactants are nitrogen and hydrogen. I've got to name one of those. To give the actual correct answer, I can't just circle 1.88. That tells me my limiting reactant is hydrogen. So I would say limiting reactant, a lot of times I abbreviate it as LR equals H2. Limiting reactant is hydrogen. Okay, then it asks me what are the substances that should be in the reaction vessel at the end of the reaction. So what should be in the reaction vessel at the end of the reaction? What should we have? Well, we shouldn't have any more hydrogen because it was the limiting reactant. It's used up. But I would have some of the excess reactant. I'm going to have some nitrogen. And of course, if the reaction takes place, I should get some product. So what should be in the reaction vessel at the end of the reaction is N2 and NH3. Products and excess. That's just the general rule. The products and the excess reactants. So that's N2 was the excess, and then NH3 was the product. All right, based on the amount of limiting reactant, determine the moles of NH3 that theoretically should be produced. Okay, to do that, we've got to look at our limiting reactant. Remember, limiting reactant was hydrogen. So I'm going to use the ratio for hydrogen over and over again. I'm going to use this ratio, 5.64 over 3. That's what I'm going to use because it is our limiting reactant. It limits how much of anything I can make or how much of anything I use. So I will always start with that as my given from now on. 5.64 moles of H2 over 3 moles of H2. And I'm just going to write MOL. It only saves me 2 letters, but I'm going to go ahead and do that. Make it easier to write. And then I'm looking for moles of NH3. Well, that's my unknown. That's X, right? X moles of NH3 over, what's our coefficient for NH3? Well, that's 2. 2 moles of NH3. Now we just cross multiply. We end up with 3x equals 5.64 times 2, which is 11.28. And I'm eventually going to round to 3 sig figs. Okay, so at this point, I need to divide both sides by 3. So x equals 11.28 divided by 3. When I round that to sig figs, I get 3.76 moles of NH3. To find your units, which are they're important, don't forget to look back at what the units for X were, moles of NH3, and make sure it's what you were looking for in the problem. I wanted to know moles of NH3. Calculate the moles of excess reactant consumed. First, we have to think back. What was our excess reactant? Well, limiting reactant is H2, so our excess reactant is N2. So I'm going to have a new X. I'm looking for moles of excess that was consumed or used. So in this case, my excess reactant is nitrogen. That's what I'm looking for, is the number of moles, X moles. What's my given? The limiting reactant is always the given after you find what it is. So we're going to do 5.64 moles of H2, again, 5.64 moles of H2 over 3 moles of H2 equals, and you go back up here, I'm looking for nitrogen, X moles of nitrogen over 1 mole of nitrogen. Now we could cross multiply and divide, or you may recognize that X divided by 1, this factor right here, is just X. So X equals 5.64 divided by 3. So X equals, and I'm just going to do that in my calculator, 5.64 over 3. You end up with 1.88 moles of N2. Whether you cross multiply and divide or whether you do what I just did, you're going to get that same answer. Finally, we want to calculate, now remember it just asks for the moles of the reactant consumed, okay? So that was the excess that was consumed. Or in other words, it was used up. Now I want to know how much is remaining, moles of excess reactant remaining. Now remember, when we're trying to find what's remaining, you got to know what you started with and what you used. Started with minus used. That should be kind of a common sense thing so that you can understand it instead of memorizing it. But if you need to know the formula, if you want to see that, it's right here. Excess reactant remaining is moles of excess reactant available, that's given, minus the moles of excess reactant consumed. And that's what we find, what we just found in the previous step. So how much nitrogen was I given? Well, I had 2.75 moles of N2. So the N2 remaining equals the original amount. Again, the original amount of N2 was 2.75 moles. Minus, and I used 1.88 moles. 2.75 minus 1.88. And I get 0.87, 0.87 moles of N2. All right, there's one more example problem. If you feel comfortable with it, work it yourself and just check your answer.